most people actually ask, who's the mother of the internet? and my son wants to know if he's the brother of the internet. So, first of all, I think internet was designed to be very capable of evolving. And so, for example, there's something called Internet 2, but it's a little misleading because, in fact, it was largely a replica of the internet, but running as fast as possible, increasing speed. So I don't think we've really seen the next generation of internet. It may emerge in ways that we can't anticipate. The current design is pretty flexible in terms of adopting new technologies, but I will tell you the one invention or discovery that I know would transform the system, absolutely without question. And that is the possibility that you could communicate using quantum entanglement. Now, some of you have seen the news reports about neutrinos going faster than the speed of light. I think that there's a lot of work to be done to figure out exactly what the measurement was and why the 60 nanoseconds happened. And quantum entanglement is not communication. As far as we know right now, when you entangle two particles, let's say two photons, their state is linked. And when you separate one entangled photon from the other, and then you inspect the state of one of them, maybe it's spin up or spin down, you know instantly that the other one, if you were to look at it, would be in the complementary state. That's not communication, that's correlation. But there is something odd going on, because if you measured spin down, you know that the other one is spin up. So they're linked in some way, which is not a function of distance. Einstein called this spooky action at a distance. Now, if it were possible to force the state of one of those entangled photons to the state you wanted, then you would be communicating, because you would be modulating the state of the photon or whatever other entangled particle you were using. Now, in order to take advantage of that, you still have to move one of the entangled pair to the place that you want to communicate to, and so far as we know, you are still limited to the speed of light to get to that destination. So you can't start using quantum communication, even if it worked, until you got the entangled particles only at the speed of light to where you wanted them to go, and then you'd have to have a big enough collection of them to signal for a while. The nearest star is 4.4 light years away, so you would take, and now the question is, how long does it take to actually get there? So we still don't quite have the kind of dramatic change that would occur if we really could communicate, like they say in Star Trek, through subspace radio. If, however, it were possible to do that, then all of the protocols that worry about round-trip time delay and control and everything else would no longer be very necessary, because there would be no delay. You would have instantaneous transmission and receipt of the data. You could instantaneously broadcast over arbitrarily long distances. That would be unbelievably dramatic. A whole new set of protocols would make sense. There are things that the internet did not succeed in doing that it should try to do, even in its current incarnation. Example. When you use Wi-Fi, you're using effectively a broadcast radio transmission, but we turn it into a point-to-point link. Why not take advantage of the fact that if you're broadcasting, if you have an omnidirectional antenna, it means that a single transmission could be received by multiple parties. If the same information has to get to multiple parties, it's the most efficient way of getting the data there. So I have this desire to get satellite communication to do broadcast IP, so that I can transmit data that a lot of people need and have it rain down on 100 million receivers. Not all data needs to be received by everybody, but for that class of data that needs to be received by a large number of parties, it's so much more efficient than multicast. We haven't even begun to exploit that. And you could do it even in the current architecture if we just introduced the notion of broadcast in a way that could take advantage of radio. That's just one example of places where the internet did finish its job and could be extended without actually having to start